Hey there, guys. Welcome to Unit 2, Notes 3, Solving Systems by Substitution. Mrs. Matheson here. Our learning target today is I can solve systems using substitution. So we've looked at solving systems by graphing. We looked at solving systems of inequalities, and we did that by graphing. But now what we're going to do is we're going to solve these without even graphing. But we have some steps you have to write down. Pause the video. These are going to be a lot of steps to write down. Steps for solving systems by substitution. Well, first, you're going to solve one of the equations for one of the variables. Okay, so you want to make sure you have an x equals or a y equals to be able to use substitution. Then you're going to substitute that expression into the other equation. You're going to solve for the remaining variable. So if you plugged in for x, now you have just y's, etc. And then our last step is substitute that value into either equation and solve for the remaining variable. So pretty much we're solving one equation, we're plugging it in, we're solving for the variable, we're plugging it in. All right, but there are two types of solutions that might not get us an ordered pair. Just like we talked about with graphing, we have infinitely many solutions. We have no solutions. We also do with substitution. So infinitely many solutions occur when both variables cancel and what is left is true. So that would be something like -2 equals -2. That's a true statement. If you have a true statement, we get infinitely many solutions. But if both variables cancel and you get something that is false left over, so maybe you have -2 equals 7, that is false, then it has no solutions. This is one that kids forget about, so keep this in mind when we're working through. Okay, so let's try substitution. So step 1 said solve an equation for a variable. Well, we already have one solved for x equals. So now we're going to substitute, here's the substitution part, that back in for x in the other equation. So we have 2y plus 36, that's replacing the x, and then we continue our other equation, plus 2y equals 8. So now we have dealing with just our y's. So now we're going to solve for the missing variable. We have 2y and 2y, so they're on the same side. That gives us 4y plus 36 equals 8. We're going to subtract our 36 over, and we get 4y equals -28. Divide both sides by 4. So we're just solving for y, we get -7. But this isn't the solution. We need both the x and the y. So now we're going to take that y, and we are going to plug it back in up here so we can solve for x. So that gives us x equals 2 times -7 plus 36. 2 times -7 gives me -14 plus 36. So if we add those together, we're going to get x equals 22. And the last step that we need to do is we need to write that as an ordered pair. So our solution for this is x first, then our y. 22, comma, -7. All right, so taking a look here at problem 2, we don't have an x equals or a y equals, so we need to make one of them into it. Now the second equation looks really nice because it has an x by itself. So we're going to solve that one for x. So I'm going to minus the 2y minus the 2y. Those cancel. So we now have x equals -2y plus 15. Ooh, that's kind of dark. Let's go back to that yellow. All right. So now this is going to replace the x. But just the x, not the 2 and the x, but just the x. So we still have our 2. And then we're going to put parentheses, and we're substituting in our -2y plus 15, and our -3y equals 2. All right, I see some parentheses, so that's an indication that I need to distribute. So we get -4y plus 30, and we still have our -3y equals 2. -4y and -3y on the same side of the equal sign, so I get -7y plus 30 equals 2. So subtract that 30 over, now we're just solving for y. So we have -7y equals -28, divide by -7. So y equals, that becomes a +4. Again, we're not done. we're going to plug it back in. X equals negative 2 times 4 plus 15. So we get negative 8 plus 15. So x equals 7. So we end up with 7 comma 4. Again, that's always the thing you need to remember, is to plug it back into an ordered pair. All right, so let's take a look here at problem 3. 3 is similar to problem 2. We don't have solved for a variable. So let's go ahead and we are going to add 3y and add 3y. Now think about, well, why did I pick that second equation? Because the second equation had x by itself. So we get x equals 3y. I'm going to tell you, you're going to plug that back in. Oops, not in for y. There we go. We're going to plug that in for x. So I'm going to get this started. 7y equals 26 plus 11 times, oh, not x, but 11 times 3y. I want you guys to finish this problem and solve for y and solve for x. Okay, so looking at problem 4, I see that both of my equations are y equals. So if they're both equal to y, that means that they're equal to each other. So I can plug that in place of y. So now I have 3x minus 4 equals 4 plus x. The two equations equaled y, therefore they're equal to each other. So I minus x, we get 2x minus 4 equals 4. We're going to add 4 to both sides. So 2x equals 8. Divide both sides by 2, so I have an x equals 4. Now it doesn't matter which equation I plug it back into, both equations are going to give me y. So I see my second equation looks a little simpler. So y equals 4 plus 4. My y is 8. So last step is to always put it into that ordered pair. And we end up with we end up with the ordered pair 4, 8. All right, so taking a look here, these two we notice are a little bit more difficult. Neither of them are solved for just the x or just the y. So looking at problem 5, I don't really care for a problem like 5 because it's kind of a yucky thing. But we see here that we have 2x. Now I look at the stuff on the other side and I can see that they are both even numbers. So I could actually divide everything by 2. So we get x equals 2y plus 2. Now this doesn't work every time because if we look at problem 6, I see I have 2x again. And if I try and divide everything by 2, we get x equals 3.5 plus y divided by 2. Not a good situation to be in. So only do it in the worst case scenario. All right, so I can take these and plug them in for x. We get 3 times 2y plus 2. I continue on my equation, minus 6y equals 6. I want you to solve that and get our y equals and then plug it back in to get our x equals. Now, what are you going to do with problem 6? Well, problem 6 luckily saves us. We have y by itself. So we're going to subtract the 7, and we end up with y equals 2x minus 7. That gets plugged in for the y down here. 6x minus 3 times 2x minus 7, and then continue on the equals 24. Pay close attention when you do this one. It is a negative 3 that you will be distributing through. So again, for problem 6, solve for x, and then plug that back in and solve for our y. We will see you guys later. Have a great